In mathematics, we are used to dealing with numbers or magnitudes such as 5, square root of 2, or pi. Now, vectors consist of both magnitude and direction. A vector can be represented by a directed line segment, such as this one here, where the length of the line represents the magnitude of the vector in the form of numbers. Thus, it answers the question, how much is the length of the vector? Meanwhile, the direction of the line represents the direction of the vector. This is usually quantified by an angle. A vector that connects 2 points A and B, such as the one here, could be represented by AB with an arrow. Another way to represent a vector is simply by using letters such as C. Do you know that our coordinate system could be used to represent vectors? Here we have vector A with components 1 and 2. Thus, vector A extends from the origin with an x value of 1 and y value of 2. Vector A is denoted by the point here. In a three-dimensional coordinate system, we have the x, y, and z axis. Thus, a vector in this system has 3 components. An important way to represent a vector is by using the unit vector. A vector with component 1, 0, 0, such as the one here, extends to the x-axis by 1 unit. It is denoted by the lowercase I. So, what are the components of J? J extends 1 unit along the y-axis. The components would be 0, 1 and 0. Similarly, the components of K here is 0, 1, 1. Let's look at this example. We can represent any vector with the multiples of I, J, and K. The component 3, 1, and 2 here could be written in the form of 3i plus j plus 2k. Vector valued function is a function where the domain or the input is a set of real numbers and the range or the output is a set of vectors. Let's look at the vector valued function that we have here, r of t is equals to f of t I plus g of t j plus h of t k. The input here would be t, and the range would be the vectors f of t, g of t, and h of t. These vectors are called component functions. Vector valued function may indicate the position of a moving particle at any particular time. In this case here, our input is t equals to 0 seconds, 1 second, 2 seconds, and 3 seconds. The output would be the vectors r of 0, r of 1, r of 2, and r of 3. Let's look at an example. We have r of t is equals to sine ti plus cos tj plus t squared k. Our input are the values 0, pi over 2, and pi. So let's calculate the values of r of 0, the vector r of pi over 2, and the vector r pi. So r of 0 would be, the first component would be sine 0, the second component cos 0, and the third component would be 0 squared. This is also equals to 0. Cos of 0 is 1. 0 squared is simply 0. Our next vector r of pi over 2 is simply, the first component would be sine pi over 2, second component cos pi over 2, and the third one pi over 2 square. This is also equals to 1. Cos pi over 2 is 0. Pi over 2 square is pi square over 4. R of pi is simply sine pi, cos pi, and pi square. So sine pi is simply 0. Cos pi is minus 1, pi square. Let's plot the values to give us a clearer picture of what a vector valued function is. So we have here, when t is equals to 0, our vector is 0, 1, and 0. We've learned this before. This is simply the vector unit j, which extends 1 unit at the y-axis, right? This is when t is equals to 0. Next, when t is pi over 2, we have the component 1 at the x-axis, 0 at the y-axis, and pi square over 4 the z-axis. So it should be somewhere here. This is the vector. This is when t is equals to pi over 2. And when t is pi, we have 0 as the x, the component at the x-axis, minus 1, the component at the y-axis. So this would extend at the opposite direction, minus 1, and pi square at the z-axis. So this is our final vector. T is equals to pi. We only have 3 values as a domain because this is simply an example, but the domain would be a set of many numbers, an infinite value of numbers. Let's keep track of the endpoints. So if you plot many endpoints, it might look something like a helix here, because it starts from the 0 and pi over 2 and then pi in this direction. So this is all for now. Thank you.